Welcome to Complexity Made Simple, and my name is Paul Allen. And before we get into today's fantastic video newsletter, what I'd like to talk to you about is all the materials that you can purchase to help to support the channel. We've got these fantastic textbooks that range from the simple statistical process control for small batch production. We've got the 7 quality tools for world-class problem solving, which is essentially yellow belt material. Then we move on to design of experiments for 21st century engineers. Every engineer and scientist needs to be able to do design of experiments. And then finally, drink tea and read the paper. The most fantastic green belt handbook you can buy on the market today, full of practical tips and fantastic physics that'll help you become a world-class engineer and a world-class quality engineer. Of course, you can also click on the link to buy me a coffee and make a donation. That would be fantastic. But at the very least, click on subscribe, click on like the video, because it all helps to support the channel. Many thanks for your help, and now on to today's video. Welcome to the latest video, and in this video newsletter, what we're going to talk about is a question from a viewer about the effect of measurement error on total error. So let's get straight into this and take a look at the question that I've been sent. Hello Paul, working on my grad thesis, and I have a question for you if you have some time to answer it. Of course I've got some time. I have a manufacturing process which involves pressing up to a certain distance. After that, an LVDT gauge is used to measure the slot thickness remaining after pressing. The gauging is done to know the dimension of the slot so we can lock it with a snap ring circlip. Now I know there will be some variation in the system. I've conducted an R&R for the gauge. I am stuck as to how can I relate the variation due to pressing and measurement to the total variation. Thanks in advance, Pranjal. Okay, now I think I've done a video on this before, but it's worth just using Pranjal's question to just go into measurement system analysis again and the effect of measurement error on total error, because it is really important. It is part of what you're always seeing in your data. So let's take a look at this now. First thing I would do when I'm trying to understand a process, I'm going to do a CPK analysis. Not just a CPK analysis. Normally what I would do is I would go run chart, histogram, CPK. That's what I would do with a data set. Where would I get the data set from? Well, normally what I would do is I would run the process 40 consecutive pieces with my hands off the machine so that I can evaluate the natural process behavior. Then I go run chart, histogram, CPK. And of course on one of those, especially the CPK, what I'm going to see is a distribution. Okay, obviously this blue distribution is the total variability that I'm seeing. Now the total variability, of course, comes from two places. It comes from the process itself, but then it also comes additionally from the variability in the measurement system. So what does that do to the result? Well, it looks like this. The process itself will be the red distribution. So there's the process variability. Now the process variability is always smaller. The process variability is always smaller than what you're observing. What the measurement variability therefore does is always make the total variability bigger by a certain amount. And of course, what an MSA does is it tells you that inflation rate. And often that's one of the numbers. So it depends which software you use, which technique you use. Precision to total, if you work out a precision to total variability, it might say, let's say 0.4, which really means 40% of the total variability you are seeing is coming from the measurement system. Okay, so that's what measurement error is doing. It's inflating the variability. Now, if you wanted to try and understand the effect mathematically, or you wanted to say, if I halved the variability from my measurement system, how much would I affect the total variability of the result? This is how variability interacts with one another. So what we've got here is total variability. And we know that it's made up of those two components. It's made up of process variability plus measurement variability. Okay. But mathematically, we cannot add the two standard deviations together like that. That doesn't work in maths. We have to do something slightly different. The way this equation actually works is everything must be squared. So if you square the process variability, you square the measurement variability, then you can add them together. In other words, you're adding the variances together. You're not adding the standard deviations together. So if we take an example, let's say that the process variability contributes 4, standard deviation is 4, and the measurement variability, the standard deviation is 2. Let's just use that and just plug it into our little equation. So of course, what people assume is that 4 plus 2 would equal 6. But that isn't the way you do it with standard deviation. That doesn't work. And you'll see the difference here now when we do add the variances together. So if I square 4, I get 16. If I square 2, I get 4, which means what I get, of course, is 20. But that's total variability squared. So in order to get back to total standard deviation, I'm going to have to take the root, which I think might be 4.6 something. I can't say I can do that off the top of my head, but it's somewhere between 4 and 5 anyway, I know that. So you can see this number, look, is very different to just adding these together. So that is how you add standard deviations together. You can't add standard deviations. You add variances. And of course, if you said to yourself, well, if I reduce this thing from 2 to 1, what would that create? Well, it would create 16 plus 1. Now you're doing the square root of 17, which is probably 4.1 something, maybe a little bit more, 4.2 something. So you can see that, you know, by knocking 1 off the variability of the measurement system won't get you 1 off the total standard deviation. But if you want to understand those numbers, maybe make a plan, maybe you've got a problem like this, lots of variability in your measurement system, and you want to make a plan as to what to do next, then of course you could say, well, if I can halve that standard deviation, what effect will it have ultimately on the result if you want to do that? Obviously, if you've got a poor capability here, So if your capability is not very good, you're producing defects, you've got a CPK, let's say 0.75, so you got yourself a problem. You need to improve the variability. Obviously, there's two places you can go. You can go to the process, try and improve the process variability. You can go to the measurement system, try and improve the measurement variability. Both of those will help you. But of course, if this is quite small, you might work very hard here and have very little effect. So the measurement system is telling you where the variation is coming from. Therefore, you can then make a plan. I need to attack some of this, but I'm gonna have to attack some of this. And obviously the CPK is telling you what the cost of all that is. So in other words, if you're gonna spend some time, what's it gonna be worth when I eventually sort this out? So total variability is made up of components like that. Measurement variability always inflates the result, and if it inflates it enough, it's worth attacking it to improve your CPK. It's part of your CPK solution potentially. But of course, really, what you want to do is, if you do new product introduction properly, you shouldn't launch a product like this. So all of this should be tidied up when you do your PPAP and things like that at your new product introduction stage. What you should do is do this analysis, understand the lack of capability, put controls in place to get capability, and get rid of all of this nonsense before you get a problem. Too many companies implement chaos, so they'll implement a process that looks like this. Then when the pain gets bad enough, they'll eventually do a Six Sigma project on it or some kind of quality project on it. Why don't you do fantastic new product introduction? Do it right, use FMEA, get the process under control, do all of that great stuff, and then you don't need to do projects after you've launched new products disastrously onto the manufacturing floor. So Pranjal, hope that answers your question about where the variability falls for measurement system analysis and the manufacturing process. If you've got any more questions, Pranjal, I'm happy to answer them. And by the way, if anybody's got any comments or some important questions that they want to ask, please send them in. I'm always happy to make videos to explain concepts that I've missed or tricky little special situations where people need extra special help. But for now, I'll see you again in the next video.